we have LRU, least recently used page replacement. This is just an approximation of optimal page replacement algorithm, because optimal page replacement algorithm is quite difficult to implement because of the future knowledge, how to anticipate what is going to happen in future. So we use the recent past as an approximation of the new future. We just replace that page that has not been used for the longest period of time. Just take optimal page replacement and think backward. What we'll do here is, if this is a reference string, see, 1 will come here, 2 will come here, 3 will come here, and 4 will come here. There will be 4 page fault because initially the frame will be free. Now see, now the one will, one will come, so there will be no problem. One is already there, 2 is already there. Now 5 has come. What this 5 will do, this will replace 3, because 3 was not being referenced. 3 was not being referenced for quite a long time. So now this 5 will replace this 3. Now 1, 2 has come, 1 and 2 are already there. Then 3 will come. So 3 will replace, this 4 will replace, or 3 is going to replace 4, because 4 again was being replaced or was being referenced quite earlier, before 1, 2 and 5. So we are not able to, or will not replace 1 to 5, will replace this 4 with 3. Now again this 3 has taken place, now 4 will come. Again we see 5 was 1, 2, 3 was referenced just now, 5 was referenced earlier, so we'll replace 4 with 5. Now again 5 has come, because 1 was referenced earlier, it was not recently used, so we'll replace now 5. This is how it is done. We'll take one more example. This is 7. 7 will come, 0 will come, 1 will come. Now which is the oldest? This 7, not being referenced just now. So we replace this 2. Now this 0 has come, it is just being referenced. Now 3 will come. So we have to replace, 0 has just been referenced and 2 has come early, just now, before 0. But this 1 was earlier than 2 and 0. So 3 will replace 1. This will be replaced. 0 is already there, 4 will come. 4 will replace what? 2, because it was earlier. It was least recently used. 4 will replace this. 2 is already, then 2 will come. 2 will replace 3 this. Okay, because 3 was quite earlier. Then next, if 3 comes after 2, we have to replace this 0. This 3 will replace. Then 0 will come, we will replace this 4. Now 3 and 2 is already there. Now 1 has come. 1 has to replace, 1 will be replaced by 0, because 0 was quite earlier than 3 and 2. So this is the case. Now 2 has come. Since 2 is already there, will not replace. Now 0 has come. We have to replace 3. It was quite earlier. 3 will be replaced. 0 will come here. Now 1 is already there. Now 7 has to be seen where we have to put. 2 was earlier than 0 and 1, least recently used. So we will replace this 2 with 7. How many page fault? 12 page faults here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Number of bars you can count. So there are 2 ways to determine the order of frame, defined by the time of last use. Because in least recently used, how we know that which one is least recently used? We can use a counter, we can use stack. So in counter, each page table entry has a time of use field, right? In page table only we'll put the time, and the CPU gets a logical clock or counter, so that we may be knowing which is least recently used. So whenever a page is referenced, the content of this clock or this clock register are copied to the time of use field in this table and in the page entry table for that page. If you want to see the stack version, whenever a page is referenced, it is removed from the stack and put out on the top. Removed and put it on the top. So the bottom one will be the page which has to be, which is the victim, which has to be removed. So this is how it is done. This is stack. So this is stack after B. We can use this. So whenever this is referenced, say 4 is referenced, then 7, then 0, then 7 has again come. When 7 has come, we have to take it, means you have to swap it out, or you can say in terms of stack, we do push and pop. So we will pop out and put it on this 7. This is recently used. This is how it is done. So neither this optimal replacement nor this LRU replacement suffers the Wiley anomaly.